Hello, today I will be talking about federated clouds, emphasizing upon the fact the services that they provide. So we already know that how cloud computing has changed our recent computing instances and how we deploy applications upon different regions and how we deal with application development and service deployments. We already know how cloud computing is currently being defined by NST. They define cloud computing as a model which enables us an ubiquitous, convenient, and on-demand network access to a shared pool of computing resources that can be rapidly provisioned and released with minimal management effort. So now we can efficiently provision resources upon our need without thinking about management as a limitation. All these management will be handled by the cloud providers, including the security which is crucial for any application. It also includes a pay as you go model, which means you will be only paying for those resources which you will be using currently or which was actually utilized. The scaling is also handled by the cloud provider, where you can rapidly and with automation provision resources whenever there's a huge source of requests upon your application in that instance, and automatically unprovision the resources when the request or traffic becomes very low. So how we came up with this problem? What was the problem that the recent cloud computing provided us? So, as we know, as cloud computing boomed, there were several heterogeneous and independent clouds, irrespective of being them private, public, or community cloud. Someone came up with an idea: what if we can, merge all these clouds and they can efficiently come, and then we can come up with an efficient solution where if we don't have enough resources in just one cloud provider, we can provision the resources from another cloud with a uniform communication system. But the problem was this communication system was not very trivial, but at the same time not impossible to implement. And for such a solution, so that different heterogeneous clouds can communicate with each other, we had to come up with a system that is very efficiently fault tolerant and can efficiently handle automatism and scalable without harming the cloud elasticity for any of the cloud providers. How this heterogeneity, though it evolved, was this heterogeneity came due to the fact that every region had their own SLAs, service level agreements, due to the difference between regions and regional policies by the government. There were also limitations due to different cloud providers creating each of the cloud. There came the efficient solution, that is the federal cloud computing. Federated. I'm sorry. I would like to correct the federal to federated. So, federated cloud computing can be defined as a set of cloud computing providers, public and private, connected through the internet. And among its objectives, we already talked about how federated cloud computing should be fault tolerant and should handle automatism and scalability without any major limitation and sacrificing the cloud elasticity. So we distinguish the seemingly availability of unrestricted resources, independence of a single infrastructure provider, and optimization when using a set of distinct resource providers. So what does that mean is, irrespective of two clouds being developed by a different cloud provider, federated cloud computing provides a uniform way for each of the cloud services to be connected with each other without having the limitations of compatibility, and these things are actually handled by the federated cloud computing itself. That means the cloud providers don't have to implement an external SLA or any compatibility module just to be added into a federated cloud computing architecture. And this actually came into reality as a solution we have as a solution a federated cloud computing architecture should always follow these requirements, which is automatism, application behavior prediction, mapping services to resources, interoperable security model, and scalability in monitoring components. An important fact for an cloud computing model is its automatism. It should handle so it should always effectively handle all the cloud providers coming and going efficiently without having the management to interfere, or without having a physical interference from the cloud providers. It should efficiently handle the automatic provision for a cloud provider A, and also whenever the cloud provider A decides to leave, all the information and the services should be handled by the federated cloud computing architecture itself. Then there's the application behavior prediction. As we came to know, how can a cloud A can predict how much resources can be provisioned from cloud B, and at that time, if even cloud B can at least provide that many resources that the cloud A wants. This is again handled by the federated cloud computing, where where a monitoring service continuously provides information for the cloud, where the monitoring service provides transparent information to the cloud A from the cloud B, irrespective of them being a heterogeneous computing model. Then there's mapping services to resources. Irrespective of the fact how many cloud providers are connected to the federated cloud computing, all the resources that a cloud that an individual cloud provider can provision should be mapped continuously at a given time interval, and should be in real time true. That information should be reliable, so that every cloud provider instance can actually handle and can actually rely on that information and provision resources as it deemed feasible. Interoperable security model. One of the advantages of federated cloud computing architecture is the cloud providers don't have to implement their individual security management models for the federated cloud computing architecture. Especially, they can implement their own security model according to their own requirements, and the federated cloud computing will automatically be handling all the security measurements. Scalability in monitoring components. As we know, since we are going to use a heterogeneous model of cloud computing, it's important that you can also monitor different components right now being utilized in the right now being used in the application. It should also be able to handle different addition of modules, and should also be able to handle different cloud providers being added into your own application. Now we come into, since my module especially emphasizes on the services part, I will be introducing subtly about the federated cloud computing architectures and the component that it involves. Here's a short diagram so that you can understand things from. We have cloud coordinator. There are three components that are majorly involved into making a federated cloud computing architecture. That is our cloud coordinator. Second is our cloud broker. Third is our cloud exchange. Cloud coordinator. This module is actually the module that encompasses all the management related issues for the whole federated cloud computing architecture, and it upon its condition, it will be responsible for assigning resources of the cloud to the remote users based on the quality of services they demand and the credits they have in the cloud bank. So the whole cloud coordinator will be responsible for handling all the innate services that will be coming, the innate services and service requests that will be coming from the user, and will be and according to the settings and configuration that has been configured in the cloud coordinator, it will be assigning those resources from a heterogeneous pair of cloud. So if a cloud A does not have enough resources for to handle the request, the cloud coordinator will be responsible for finding another cloud provider that will be able to handle that following request, and will also be able to and the request, the user who has sent the request has enough credit, and it will be also checking the how many credits the user have in their cloud account, so they can come up with an efficient solution of connecting different hardwares of the different cloud providers. Then there is cloud broker. Cloud broker is the middleware party between the cloud computing users and the cloud coordinator, which will be responsible for finalizing the suitable deal between the cloud coordinator and the users. It also will be responsible for handling SLAs, and it will be carefully analyzed by the cloud broker, so that there is an efficiency of efficiency of provisioning of resources, and all the security measures and the agreements are being signed upon. The third component is the cloud exchange. Cloud exchange is actually the module that will be responsible for connecting all the modules and the providers that are connected into the service. It handles requests from the cloud broker and maps all the requests to the available resources from the cloud coordinator. It even tracks the present cost, demand cost, and patterns, which periodically gets updated. So this module will be actually handling all the real-time resources, and will be having a data structure which will be responsible for containing all the mapped resources currently in a cloud provider, so that if cloud provider B has enough resources like 8 GB free, it will be stored in a hash map data map structure for the cloud exchange, so that it can be retrieved by a cloud A provider whenever they need it, and that's all. Now we come to the federated cloud computing services. So there are a few services that I would like to talk about. We have for a federated cloud computing architecture to really be provisioned perfectly, created and coded efficiently, it has to contain some 6 services that are: first is monitoring service. So any monitoring service that should be involved into a cloud computing architecture should be having these characteristics, that is scalability to handle many resources and tasks to be monitored, elasticity to handle multiple additions and removal of a member cloud service without any hindrance. So what it means is, monitoring service is actually responsible for monitoring all of your requested tasks. The service might be periodically sending, and will be responsible for handling all the status of your processes that are currently running in the whole cloud. So it receives tasks from the job controller that will be involved in your cloud exchange component, and will be transferring them to the scheduling services, which in turn distributes them to the computing services to complete the workflow. So this service will be actually responsible for monitoring all the services and transferring them to the scheduling services, so that in turn decides which cloud provider will be actually responsible for running this process or workflow. Then there is security services. Any security service that is implemented by any module should always be implementing authentication module, authorization module, and the confidentiality module. This guarantees there's integrity among the cloud members, and there's integrity between the running tasks. That means the task in middle was not breached, and all the data could be actually relied upon, and it ensures all the security context and policies for the cloud members the cloud providers remain independent of each other, so it doesn't create a hindrance between any of the cloud providers itself. Then we come into discovery service. So this service is actually be supposed to handle all the information about the resources that a different cloud provider can provide. It will be continuously running in the background and updating the status of the resources in the different cloud providers. This ensures that there is high availability among the different cloud providers involved in the federated group. And whenever a cloud provider might need this information for the other cloud, this service will be able to provide that cloud provider with the information about the resources from the other cloud. So it is important that the resource discovery infrastructure should be capable for the following requirements, that is the scalability, which will allow it to handle thousands of machines with high availability and performance, so that whenever a new cloud provider gets connected to the federation, it should be easily able to handle the resource management from that cloud, and it should be flexible enough to handle all the queries from different cloud providers itself. Then there is scheduling services. Scheduling of tasks is an important task for any kernel or any cloud computing service. So a task scheduling is kind of different in a federated cloud architecture, federated cloud environment, where cloud provider A might be sending a different workflow to a different cloud provider, and a federated cloud service actually handles it dynamically and distributes all the tasks among the cloud providers, which in turn maintains a register for the allocated task. It is responsible for synchronizing all the tasks with the cloud providers and the services that they provide with low latency, and it is responsible for choosing which task to run before any other task. Then there is storage service. This service is actually responsible for handling the model of the storage strategy which the whole cloud federation will be actually be encased upon. So the storage service will be handling all the information received from the discovery service, and it will distribute and replicate all the data in the federated cloud among the cloud members. And based upon the information that will be received from the discovery service about the file, the federation cloud, the storage service will be actually responsible for deciding which file will be getting stored in which cloud provider. Then there is the last service, that is a fault tolerance service. This is a crucial service that will be actually responsible if a cloud provider A suddenly goes AWOL, and there must be some algorithm or maybe some threshold that should be decided, that would decide what if a cloud provider is not sending a heartbeat. That means it could be a reason that it could be dead, or it might be a subtle network fault that is actually creating latency among the cloud providers to the connected federated cloud architecture. But anyways, we have to handle it efficiently, and one way would be to actually adopt an approach where if the elapsed timing for a cloud provider being disconnected from the federated cloud is actually greater than some threshold, it should be removed immediately from the federated cloud architecture, and would not be allowed to join until and unless it has a manual intervention from the cloud provider itself. Yeah, thank you. That was my presentation, and yeah.